Hello, Algebras. Welcome to your Chapter 2, Lesson 1 notes on measures of center and range. So we are going to talk today about figuring out the best way to look at our data and determine who is the middle data value. And that's definitely like a depends on the data situation, because when we're analyzing data, there's lots of ways we could consider a middle. And so our measures of center are considered a mean, a median, possibly a mode. And so we need to define ourselves the mean, median, and mode, and then look at how those could look when put into a data set. So let's start with the mean. The mean is the average. It's when you add up all of your data values and divide by how many data values you had. We're going to call this X bar when we're working with this, because that's going to be our symbol in our graphing calculator. The median is the middle data value. And if your set of data values is even, you would take the two middle data values, add them up, divide by 2, and find that average for the middle data value. Whereas the mode is the value, the data value used most. As we talk about the mode in its specific section, we will find that you could have no mode, you could have multiple modes, you could have one mode, and it all depends on the data set that we have. The range is the maximum data set minus the minimum data set. It's the largest minus the smallest. It's what is that full amount of data that we could cover. And you'll see as we go on throughout these lessons talking about stats that the range does become valuable to know based on what types of data we are looking at. Okay, so when we visualize our data, how we like to think of mean, median, mode. In a very normal data distribution, meaning there is the same amount of stuff on both sides, and most of the data is falling in this regular middle, then the mean, median, and mode will be approximately the same value. So they would all be kind of the same. What we're going to learn as we start to visualize our data and put them into different charts, like a box plot, a dot plot, a histogram, these different charts that will show us what our data looks like, we'll start to learn that sometimes our data is going to skew one direction or another. Your data is skewing left, means it's tailing off to the left-hand side. So the tail on the left. When the tail is on the left, we call that a left skew. Okay? And where that is the case, what that means is the average data value is pulling everything else towards it, right? And so you're going to have your most in one spot, but your average is still going to be higher or lower than that, okay? And the same thing goes, lower than that, because one data value is really throwing the whole skew off. Whereas a right skew, so your tail is over here to the right, so the tail of that data is off to the right. This is a right-hand skew. That's how we know which direction our skew is. This is where you've got one data value really pulling up your average, but most of your data is below that middle. And so these are where the data is moving one direction or another, where the majority of the data is not in the middle like this normal distribution. So that's when you'll find that the mean is bigger than the mode. Okay, so what are we going to learn today? Well, we're going to talk about who should be the middle then when we've got skewing. And we're going to talk about how to find the mean and the median using our graphing calculator. Okay, so that's what we really want to get into, is using that graphing calculator. Let's start with the mean, the average. Now, I know that all of you want to look at the mean and say, oh, well, that's just add them all up and divide by however many I have. And you're absolutely right. But I want to show you a way to do this on the graphing calculator that helps you get that right away. So if I'm looking at exercise 1, and I'm going to use this with my graphing calculator right now. Ralph's grades on 5 tests in his science class are 93, 80, 86, 72, and 94. And we want to know the mean and the range of Ralph's test scores. Now, I want to show you how to do this on your graphing calculator. So hold your graphing calculator, and what you want to make sure you press is stats and this edit button. So stat enter. In L1, we're going to type each data value. So 93, enter. 80, enter. 86, enter. 72, enter. 94, enter. We're going to type all those in. Okay? Now, if I go back and press stat again and arrow right over to this calculate, I can actually calculate the mean and a couple other data values that I need. Okay? So let's do that. Let's press enter on one of our stats. We put all our stuff in list 1, so that's what's written right here, or typed right here. And now just press enter until it calculates. X bar is 85. So I know now that the mean or average of my data is an 85 for Ralph's test scores. Now this is a really cool part of finding all the data stuff. So there's a whole bunch of other stuff that's spit out. The important stuff right now for us is this N value. That's how many data values we had. We typed in 5 grades, and so we typed in, and that is our number of data values. Then look, we've got a little down arrow to the left here. So if we press our down arrow, we see more information. And these things down at the bottom are called my 5-number summary. If you look, they give me my maximum test score and my minimum test score. So if we want to find the range of our data, we take the maximum, which was 94, minus the minimum, which was 72, and find out what that is. Now notice your graphing calculator doesn't do that part for you in this data spit out, but you use that maximum and minimum together to do it yourself and find that your range is 22. Okay? So is the average the appropriate test score for Ralph in this case? I think so. If we look at Ralph's test scores, okay, he has a couple grades above an 85, a couple grades below an 85, right? So, I mean, he's got a pretty good amount that's carrying him. That's a pretty good measure of center in this case. It's not always the case, so that's why we ask that question. So we will say in this place, yes, because 85 really is very close to the value that is in the middle of all Ralph's test scores. Okay. Now, let's move on and talk about the median. So the median is the middle data value when we arrange our test scores in chronological order, largest to smallest. All right, so let's see. If we look at 7 employees at a car wash, and their ages are 17, 19, 20, 17, 46, 17, and 18. Woof! It says the mean is 22. You know what? Let's prove that by practicing using our graphing calculator again. So grab your graphing calculator and press stat and enter to get into this. Now, I actually want to come back to Ralph's test scores in a minute, so I'd like you to arrow to the right so that your cursor is in L2, and let's enter these car wash aged employees in L2. So 17, enter. 19, enter. 20, enter. And keep entering your data values. And as you're entering them, does something kind of pop out to you as maybe not fitting in with the rest? Does this 46 really fit in with 3 17s and an 18 and a 19 and a 20? it's a little bit higher than the rest. So that when I press stat and arrow right to calc, I want to perform one var stats. So I press enter, but this time I need to change my L1 to match where I put my data. So I'm going to press second and 2 to get this to change to an L2 to run my one var stats on the data I just entered in L2. Now we will press enter until we calculate, and yes, so our question that said the mean was 22, that's correct, okay? So the mean is 22. What's the median? Well, actually, I didn't point this out last time, but the median, if you arrow down, is the MED in our 5-number summary. Wait, now look at this. Let's reorder this data, just like your graphing calculator did, to see what is going on here. Your graphing calculator has to reorder the data for itself and then perform the different operations on our data to spit all this out of one var stats for us. What do you notice? Yeah, indeed, 18 is the median. It is the middle data value out of our 7 data values. But why doesn't our mean match it? Well, because this value is so much bigger than all the other values. It's skewing the mean. It's making the mean, the average, seem so much higher because of that. Okay? So that's the reason in this case, because you've got this skewed piece, the median is the best measure of center. Okay? The median is the best measure of center in this case because your data is moved this direction thanks to the 46. Okay? We've got a tail and then a boom over here. This is your tail. All right. Let's keep going and talk about the mode now. So I've got these 2 sets of data that I've already looked at. Now we want to talk about the mode, which is where we look at if a value is used more than once, who is used the most. And so not all data sets will have a mode. There are several different scenarios where there might be no mode. There could be scenarios where you're using the same data value several times, and that is the one mode. There could be a scenario where you are using multiple data values multiple times, and there's multiple modes. So let's look at all of these situations, okay? All right, let's look back at the employees of the car wash, 17, 17, 17, 18, 19, 20, and 46. Who's used the most? Just 17, so our mode is 17. Notice if we think about that very last thing we just did, that 17 is nowhere near the average, okay, nowhere near the mean. And so that does tell me that there's a skew there when that is the case. That amount that's used most is farther away from the mean. The mean is higher than that. All right, the number of hours spent by each of 6 students reading, 6, 6, 8, 11, 14, 21. Who's used the most? 6 is the only one used more than once, so 6 is the mode. Looking at number of photographs Renee printed from her last 6 rolls of film. So 8, 8, 9, 11, 11, 12. Ooh, there's 2 modes. 8 is used twice, and 11 is used twice. So 8 and 11 are our modes. Ooh, how about the number of people living in each house on Merrill Street? 2, 2, 3, 3, 4, 5, 5. Whoa! 6 and 8. 2 is used twice. 3 is used twice. 5 is used twice. This has 1, 2, 3 modes. 2, 3, and 5. Now the last one, we're back to Ralph. There is no mode. Ralph did not get the same score on any one of his 5 science tests. This is where we would just write no mode. Notice it's not 0, because 0 would be a number, a value. And Ralph didn't get a 0 on a test, so he can't have had a mode of 0. No mode is present because no data value was repeated. All right. Very good. Now, I have explained using my demonstrating on my TI-84 plus CE on the screen exactly how to enter Ralph's test scores on his science tests into L1 and then running one var stat on that. So this actually shows you how to do that as well using the graphing calculator screens that I have just shown you. Okay? Just so you know, those are all there for you. We're going to do that one more time in exercise 5. So actually what I am going to do is I'm going to go to stat. I'm going to go to enter. So I'm on my page that has all my lists. And this time what I'm going to do is arrow right to L3, and I'm going to enter this data in L3. So we've got 0, 3, 1, 4, 3, 2, 2, 0, 1, 2, 3, 1, 2, 2, 3. Oop, oh, not negative. There we go, 3. Now, that was a lot. So I'm actually going to just double check that I have the right amount of things. So it was the number of siblings for each student in an English class. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 data values. And notice right here on my screen, my graphing calculator is actually asking me for a 16th data value that I don't have. So I know that if I go up 1, that was my 15th data value. I entered the correct number of data. So when you've got a lot of data like that, it's helpful to do that little quick check. How much did I just enter? Do I have the right amount? So now press stat, arrow right to calc, and let's do one var stats on our L3 data. So that means that we have to change which list we're pulling this data from. To get L3, notice it's this blue among 3, right above 3 right here. So we press second and 3, and that changes to list 3. And so now if I press enter to calculate, oh boy, look at that mean. That's my X bar. I can put that repeating bar over 3. So this is 1.93 repeating, very close to 2. There's not going to be a 1.93 number of siblings, right? That's part of the issue with mean as well. It's not going to give me a whole number sometimes. Now if I arrow down, I do see before I even arrow down that n equals 15. I had 15 data values that I entered, and I can see my range is my maximum of 4 minus my minimum of 0. 4 minus 0, of course, is 4 as my range. I look for my median, and my median was 2. Now, what do you notice isn't in the data? My mode. So I have to figure out my mode all by myself. So let's look. Okay, well, 0 got used twice. 1 gets used 3 times. Ooh, how many times did 2 get used? 1, 2, 3, 4, 5 times for 2. And how many times for 3? 1, 2, 3, 4. Oh, so close. And then 4 only got used once, so my mode must be 2 because it was used the most. I would personally call this data set normal because the majority of the data is right here in the middle, including that mean, okay? So most of my data is right here in the middle. There's a little bit of a tail on each end. So what would I use to describe a typical number of siblings? The mean, median, and mode are all the same, so could each be used. And one last time, as we're visualizing that data, when they're all the same, any of those are considered your measure of center. Okay? Once you have a skew, it is best to pick the median as your correct measure of center. So the second you're skewing one direction or the other, and the median and mean are farther apart from each other, pick the median as your typical measure of center because it's actually a data value present. The mean might not be an actual data value present because of pulled either direction by a big or a small data value. And that's the stuff we're going to keep talking about as we go through and look at our data. And now we're going to go through also in these next few lessons and visualize this data using dot plots, box plots, and histograms. All right, you guys practice on 2-1 homework, and I will see you soon to talk more about stats. Bye, algebras.